Okay. We have permutations with restrictions continued. So we have find the number of permutations of the letters in the word kitchen if the K, C, and N must be together, but not necessarily in that order. Okay? So we have to have the K, C, and N together, not necessarily in that order. Do we have any doubling or tripling up of letters?
No.
No. So we have 7 letters. 1, 2, 3, 4, 5, 6, 7. The K, C, and N must be together, but not necessarily in that order. So what we do is we hook them together. So I go to the front, and I hook these 3 letters together, because they need to be together, it says. Not necessarily in that order, though, so I don't have to go K, C, then N, correct? So how many options do I have for this first one? 3. I would have K, C, or N. Then this one? 2. Why? Why am I holding a number here? It doesn't say I can't repeat. Right, it's Scrabble tiles, right? We have this many Scrabble tiles of the word kitchen. I don't have an infinite number of letters I can use. So then 2, I have K, C, and say I hold the C, then I have 1, I have K. How many letters have I used up? 3. How many letters do I have left? 4. So I have 4 for here, then 3, 2, 1. Now this would be the answer if I said must be together at the front. Does it say that? No, it says they must be together. So we also have to count all the ways that they can be together. So I'm going to show you on a separate page. Don't write this, it's ridiculous. So we have 1, 2, 3, 4, 5, 6, 7. Currently we have this. Let's pretend that these were the letters we picked. K, C, N, T, what else do I have? H, I, another letter, E. Okay, let's pretend that those were the letters we ended up picking, right? If I take this K, C, N, and I move it between T and H, would I get a whole new different word? Yeah? Would this K, C, and N still be together? Yes, they'd still be together because I hooked them together and now I just move them directly between here. Would I get a new amount? How much does this add up to? 6 times 24. Is that 144? No. Is it 144? 144. Okay. Now, if I reordered it, this would be the T, so this would have the 4 options, and then I would have the KCN in here, which is 3, 2, 1, and then I'd have still 3, 2, 1 back here, correct? But I have totally different words. But is the total still 144? Yes. Then I could move them between these two, couldn't I? So then I'd have a 4, I'd have a 3, I'd slot them in between these letters, and then I'd have 2, 1. My total is still 144, isn't it? Then I could move them between these. And I'd still have 144, or I can move it completely to the back. I could bring all those 3 letters to the back. They'd still be together, and I'd still be getting different words, and it's 144. So how many different cases did I get? 5 of 144. We agree? So what you can do instead of showing every single case is you can figure out how you would move them. So let's go back to the question. So I have them here. This is actually counted as one case, isn't it? Okay, so that's one case. Some people will try and slot it before the 4. It's already there, right? So that's not a new case. That's where it is. So that's one case. Or you could put it between here, which is 2, or between here, which is 3, or here, which is, or here, which is. So I'm going to have to multiply by 5. You always multiply by 1 more than the number that's not after the hooked together numbers. So if this is 3, 2, 1, then this is a 4. We're going to multiply by 5 because we're going to actually get 5 cases. If this was an 8 after the hooked together numbers, we'd multiply by 9 because we get 9 more cases. Okay? All right. So How can we write this out nicely? What's 3 times 2 times 1? 3 factorial. We agree? It is also 6, so we could give the answer 6 or 3 factorial. Then people will say 4 factorial times 5. But what is 4 factorial times 5 actually? It's just 5 factorial. Because 5 times 4 times 3 times 2 times 1 is 5 factorial, right? And I told you it'll always be one more than this. So whatever you number you multiply by at the end, you're going to end up getting that factorial when you put all of these numbers together. So 3 factorial, 5 factorial, which is 720. Now this one, we did one like this yesterday where they couldn't be together, right? Yeah? How did we do that? We did total rearranging of the word, subtract off all the ways they can be together, and then what was left over was how they couldn't be together. Yeah. So, we're going to look at kitchen. How many ways can we rearrange kitchen if the vowels must not be together? So we're going to do kitchen, rearrange, total ways to rearrange kitchen, minus off the ways that we put the vowels together, and then what's left over? The ways they are not together. It'd be like me asking you, how many students are not in this class, right? You'd go to Mrs. O and you'd say, how many people are in this school? And you get the total, correct? And then you'd subtract off the people in this class, and then you'd have all the ones that are not in this class. It's the same thing. So we're going to do total, no restrictions. Minus vowels together equals vowels not together. Because if we take all the ways we can rearrange kitchen, that's the maximum different ways we can rearrange kitchen, and we subtract out the vowels together, what's left over are the vowels not together, right? It's the leftover stuff. So whenever it's not together, you never like try and make cases where they're not together. You literally just do total, minus them together, and then what's left over are them not together. So how many ways can I rearrange kitchen? No restrictions. Yeah, because kitchen is how many letters? 7. So it'll be 7 factorial or 5040. Then we subtract the vowels together. So we're going to have to do that still, right? How many vowels are in kitchen? So there's 2, so I'm going to hook the first 2 together. How many options do I have? 2 times, how many letters are left? 5 times 4 times 3 times 2 times 1. If I said vowels together at the front, I would be done. Yes? Mm-hmm.
When it says total no restrictions, what 7 factorial would be like 1 less each time?
Yes, 7 times 6 times 5 times 4 times 3 times 2 times 1.
But if it's total no restrictions, then it'd be 7 times 6.
Nope, because you have Scrabble tiles with the word kitchen on it. So no matter what, when you have words, you do not have repetition. It's not allowed. The only time you have repetition is if you have like the word pool and you actually do have 2 O's. So how many ways can I move this? 6. So we multiply by 6. It's always one more than this. If you don't believe me, it's 1, 2, 3, 4, 5, and 1 at the back. 6. So it's 6 factorial times 2, which is 1440. What's 5040 minus 1440? 3600. You guys are going to try example 2 and 3. See how you do. Okay, so we have how many ways can we rearrange oranges? And until actually this page, we haven't had to write them out. But we're going to have to write them out every single time and see if there's double up or triple ups, because after this page, it starts. So oranges doesn't have any doubling or triplings. It has 7 letters, so it's going to be 7 factorial, which is 5040 if there's no restrictions. because I make 7 blanks, and in the first blank I could have 7, then 6, then 5, then 4, then 3, then 2, then 1. The first letter must be an N. 1, 2, 3, 4, 5, 6, 7. This has to be an N. So I have 1. I've used up 1 letter. 6, 5, 4, 3, 2, 1. If you are someone who still struggles with these, write all the letters below. Like, honestly, then you won't make mistakes. Take your time, like a few extra pencil marks, and you won't get it wrong. So if you still struggle with it, then go, okay, N. Then I have O, R, A, G, E, S. That does not look like an O. And then I keep the O. Then I have R, A, G. Like, list them below if it's a struggle. And then you'll get it right. So there's no harm in that. So I'm going to get 1 times 6 factorial, which is 720. Okay, the vowels must be together in the order O, A, E. 2, 3, 4, 5, 6, 7. They have to be together, so I hook them together in the order O, A, E. 1, 1, 1. Can't be 3, 2, 1 because it has to be in that order. Then I have 4 letters left. 3, 2, 1. And then I have to go 1 way, 2, 3, 4, 5. So multiply by 5. And I get 120. How many ways can we arrange the word brains if the vowels are together? A and I, there's 6 letters, no double ups, no triple ups, and A and I are my only vowels. 2, 3, 4, 5, 6. So I hook 2 together. 2, then 1. 4, 3, 2, 1. If it said together at the front, I would be done, but it does not, so I have to multiply it by 5. So technically I have 2 factorial, or 2 times 5 factorial, which is 240. In how many ways can 3 girls and 4 boys be arranged if no 2 people of the same gender can sit together? In order for that to happen, we have to start with boys, because there's more of them. 1, 2, 3, 4, 5, 6, 7. Boy, 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 girl, girl, girl. So I have 4, 3, 2, 1. 3, 2, 1. Whoopsies, don't know what I was doing. So the red numbers actually are 4 factorial. Shh. Red numbers are 4 factorial. Green numbers are 3 factorial. Altogether is 144. I want you to do that exact same question. 4 boys, 4 girls. Go. 4 boys, 4 girls. They can't sit together. 2 genders can't be together. Try it out. 4 boys, 4 girls. How many started with girls? How many started with boys? How many remembered that you have to be able to start with boys and girls would make totally different looking pictures? You would have to have 2 cases. You'd have to have a case where you start with boys and a case where you start with girls. Because if you looked into a picture, if you looked at a picture and it started with boys and girls, and then you looked at a picture where it started with girls and boys, it would look totally different, wouldn't it? So we have to go 4 factorial times 4 factorial times 2, technically. Because you would have 1, 2, 3, 4, 5, 6, 7, 8, 4, 3, 2, 1, 4, 3, 2, 1. And that's if I started with boys. But if I started with a girl, it would be the same amount of numbers, but totally different looking, right? So you have to remember to multiply it by 2, where most people forget to multiply it by 2. Okay, we have 6 actors and 8 actresses are available to play 4 male roles and 3 female roles. They don't say they're the same roles, so we assume that they are different roles. So order matters then in which you're picked. And on a diploma, I would really hope that they would put 4 different male roles, 4 different female roles, so that you wouldn't assume either way. So that would be the same or they would be different. If they're different, we can go to the blanks. We have 4 male roles, 3 female roles. How many males do we have to choose from? 6 times 5 times 4 times 3. And then 8 times 7 times 6. We can do it like this. This also represents a permutation because the order matters, because if you don't believe me, then if you go sign up for any play and you get any different role, you're equally as happy because order doesn't matter. Is that true? No, the person who loves singing wants the top role. Person like me, just I signed up to be with my friends, don't want to really be seen. I'm just in the background pretending I'm there, not learning lines. It's kind of like a butterfly. Give me the butterfly role. I'd be really good at that. Okay, so this is something to note. This is a permutation, but we can also use P's in this way. We can use the P button when we start off with how many we're choosing from. We can go, hey, I have 6, and I have to be going down by 1 each time. Am I going down by 1 each time? Yes. Then I can use the P, and then I say how many I went down by 1. How many did I choose? 4. 1, 2, 3, 4. So 6P4, but they have to be going down by 1, so you can't repeat. And then how many did I have to choose from? 8P, and how many did I choose? 3. So we're going to type it into our calculators. So we can go 6 math over 2 and pick P 4 up times, what was the other one? 8P3. Same number. 120,960. If you have the older calculators, it's going to go 8 NPR 4. It means the same thing. It doesn't matter. So you're just using the math. You're going 8 math P, which is number 2, 4, 3. And if I want to enter more in, I have to arrow up so I get out of the subscript. Okay? Enter. So 120,960. Okay. Repetitions. Go away. Okay. This is craziness. Okay. For now, we're just going to look at basketball. Example 1. How many different 10-letter arrangements can you make from the word basketball? I put basketball and then I put basketball again. As I was typing, you didn't realize this. But are these two words different? Basketball and basketball? If you just quit reading ahead, children. If you didn't read ahead, are those just different words? Basketball and basketball. There's no 2 O's at the end. They're the same word. We agree? Yes, they are. Okay. I switched the 2 L's. Can you tell I switched the 2 L's? No, because I am super stealth. Boom, boom. L's are gone. You can't tell. No, they're not. So you can't tell the difference. So we have to get rid of the cases where your L's would swap, but the word doesn't look any different. Okay? How do we do that? Well, we treat the word on the top just like we would have the whole time. We treat them like they're all different letters and like we can tell the difference. And then we get rid of the doubles and triple ups after. So what we're going to do first, we're going to rewrite the word and stack letters if there's double ups. So I'm going to go B, A, S, K, E, T, B, A, L, L. I stack for 2 reasons. 1, so you don't miss stacking up letters. 2, if you stack them, it might be like, why am I stacking these? Oh, right, I need to deal with my restrictions of the fact that they double or triple. I just rewrote the word out, and then if there's a doubling letter or tripling, I just stack them. So now I know basketball has 2 B's, 2 A's, 2 L's. So really, there's going to be cases where basketball, I could have, okay, actually, I lied. I swapped the 2 B's. Can you tell? No, okay, I swapped the two A's now. I know, it's hard, right? So what we do if we want to rearrange basketball is we treat it like all the letters are different. How many letters are in basketball? B, A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. So I would technically have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what I would have done before, correct? And then what would I have done? 10 times 9 times 8 times 7 times 6. Instead of writing it out like that, what would I have actually done? 10 exclamation mark. Now this is the catch, and this is the reason why you stack them. You have to get rid of all the situations where they actually are not different, right? The fastest way to do that is not to draw 800 cases and try and figure out where the L's would be the same. The fastest way is to go divided by, in brackets, factorials of all the doubling letters. So I have 2 B's, so I'm going to go 2 factorial. I have 2 A's, so I'm going to go 2 factorial. I have 2 L's, so I'm going to go 2 factorial. And that will get rid of all of the cases where they're actually the same. Now, I'm going to show you something if you have a fancy calculator. So if we go to type it in like this, your calculator, I don't know if you know this, but your calculator does order of operations. So it does bed mass. So if I type it in like this, it's going to go 10 factorial divided by 2. Take that answer, multiply it by 2 factorial. Take that answer, multiply it by 2 factorial. Is that what you wanted it to do? No. So the only way we can force it to do something first is bed mass. What's the very first thing? Brackets. So I can throw brackets around the bottom. Now, if you have any calculator other than the TI-83s, the TI-83s, this doesn't work. If you have any other fancy calculator, try this. So we're going to go alpha, following along. Whenever you have a fraction, you better be using this. Unless you have the TI-83s, you don't have this option. So you're going to go alpha, y equals, enter. And it pops up a fraction. Mind blown. So you're going to go 10 math factorial. And then on the bottom, you're going to have 2 math factorial, 2 math. Do I really need to write the factorials? Because 2 factorial is 2. But I'm proving a point. And now I don't need brackets because I'm blatantly showing it's a fraction. So every time you are typing a fraction into your calculator, you need to make sure that it is in brackets. Or, yeah, in brackets, or else you're using alpha y equals enter. Not all calculators have it, but some do. Okay, so we're going to look at aardvark. Aardvark's a wonderful word. The very first thing we do when we get words is we rewrite it out and stack letters. Shh. People can hear. Whenever you listen, you're going to be listening to your aardvark conversations. So, shh. All right. So, we have, it picks up stuff. Okay. This thing picks up lots of aardvark information. Oh, I'm glad. I hope you didn't say it loudly and that this doesn't pick it up. Okay. Ready? Aardvark, stack letters. R, D, V, A, R, K. Aardvark. How many letters are in aardvark? 8. 1, 2, 3, 4, 5, 6, 7, 8. Do you know what I do? I don't even do the question first. I do this. Divided by 3 factorial, 2 factorial before I even start, so that I don't forget that. They will have the answers to you forgetting that on the diploma. Obviously. Now, the A's must be together. That's our stipulation. Remember I told you on the top we treat everything like they actually are different. So we're going to treat the A's like they're different. We're going to treat the R's like they're different. And then the bottom division gets rid of all those issues. So we're going to put the A's together. We're going to hook them together. How many A's do I have for the first blank? How many A's? 3. Then I leave 1, then 2, then 1. And people will say to me, but you can't tell the difference between them if it's A. True, but the 3 factorial on the bottom gets rid of that situation. So we treat them like they're totally different on the top, and then dividing by the factorial gets rid of the fact that they're not. How many letters are left? 5, 4, 3, 2, 1. Am I done? I have to multiply by 6. It's always one more than this because they have to be together. It doesn't say together at the front, right? So on the top, we actually have 3 factorial, 6 times 5 times 4 times 3 times 2 times 1, 6 factorial, over 3 factorial, 2 factorial. If you really wanted to get fancy, these cancel. So it's just 6 factorial divided by 2, which is 360. Six factorial, 720. Yeah. Two factorial is 2. Because it's just 2 times 1. You're not the only one. Everyone asks that question. Do not feel alone. It's reals. I should just explain that because everyone asks it. Okay. Do B and C. Try it out. Okay, if you're given pathways, pathways are literally just words. It's like sneaky words that are called DERs. Okay, so we want to go to A to B, and then it'll say only heading towards B. The reason why is so that you can't like be like, hey, oh, I forgot my keys. Hey, oh, I forgot my phone. Hey, oh, I forgot my backpack. Hey, I'm really just doing this. Hey, I can do this for life. Hey, I'm infinity. Right? You look like an idiot. Learn to take your stuff out of your house. I never remember. That would be me. Totally be me. So you always have to work your way towards B somehow. Okay? The way to do this is that you can treat it like the word der. So here I have down, 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 down. And then here I have right, 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 right. So let's pretend I have the word der. Duh. It's a really nice word. Everyone likes it. Ders. How do I rearrange a word? Remember what I do? I do the top as if they're all different, divide by their factorials, right? How many letters are there with der, this particular der? 9. So on the top I would have 9 factorial, because I'd have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by 4 factorial, 5 factorial. That's it. Boom, I have this. And then after, I'll show you the weird way to prove that I'm not lying. So what's the answer to this? 226? 126. I'm going to show you how using pathways, but you'll never be asked to do pathways because pathways makes no sense because you're not doing pathways, you're doing prims and cons. So what you would do is you'd start here and there'd be one path to get me here, one path to get me here, one path to get me here, one path to get me here. I could just walk to it. Same thing here. One path here, one path here, one path here, one path here. You do not need to write this. You're just, I'm proving I'm not lying. Okay, so then I sum my paths up. So I have one path to get me into here, one path to get me to here, so that's a total of 2. 2 paths and 1 path, total of 3. 3 paths and 1 path, total of 4. 4 paths, 1 path, 5. 5 paths, 6, 1 path, 6. 1 path, 2 paths, 3. 3 and 3 is 6. 6 and 4 is 10. 10 and 5 is 15. 15 coming in and 16 is 21. 1 and 3 is 4. 4 and 6 is 10. 10 and 10 is 20. 20 and 15 is 35. 35 and 21 is 56. 4 and 1 is 5. 10 and 1, 5 is 15. 35, 70. 126. Boom. Or you can remember der. I would go with der if it were me. These ones, you will have 2 separate words. You're going to have der times the answer to der. So how would I do the top one? Oh, 4 factorial, because there's 4 letters, divided by 2 factorial, 2 factorial, times this one. 5 factorial, 2 factorial, 3 factorial. Boom. On the next page is your homework. It's from the textbook. So just to show it to you, it's right here. I'll come back. It's right here, this. It's your homework. Remember, your unit test is next week, Thursday. Yep.